Good evening, all. You're welcome to Victoria Suite from Eternity, the School Board. Today we take a look at our chemistry review. Chemistry review. We review the assignments. I think that was Friday assignment, right? That was on Friday. So we review the assignments. Sorry for those that are joining us today. The first thing we do is to put down the assignment on the board. Then we take the assignment. Then we review the assignment for the previous day. Then after that, we now go into what we have for the day. On Friday we have an assignment. I think 10 questions. So I want us to review the assignment now before we go to what we have today, which is physics. Okay. Number one question, that's a chemistry review assignment 3. The question says, a heterogeneous mixture can be defined as a mixture A, whose composition is uniform, B, whose composition is not uniform, C, formed by solids and liquids, D, of a solute and a solvent. What's the answer? B, whose composition is not uniform. How? Explain. Explain what you mean by that. What heterogeneous mixture is all about.
It's a mixture where throughout the solution the composition is not uniform.
Okay. Example. Give us an example of a heterogeneous mixture. No. Any idea? Okay. Huh? Water and oil. Okay, actually, let us not waste our time there. Actually, if you are defining anything, that's what is called keyword or key phrase. You should always look out for, and that keyword or phrase explains everything. Okay. Now, when you say heterogeneous, the most important thing there is that a heterogeneous mixture has more than one phase. You can have two phases and above, depending on what and what that are mixed. Am I communicating? Yes. I gave in our last class. I gave an example of a homogeneous mixture as against what? Heterogeneous. I said that homogeneous mixture is a what? Is a one-phase mixture. Just get salt and put in water. The salt will dissolve. If you look at the water, you won't even know that it's a solution. You would think that it's ordinary what? Water. But it's only when you test it you will know that there's something else in the water. I gave an example where when we are kids, one of our neighbor used a solution or a sugar solution to cook rice, thinking she used ordinary water. It was after cooking that the whole rice was tasting sugar, and they had no choice than to bring it out for the children to eat. So we gathered and ate it, and we are saying that we ate rice sugar, But the point there is that on looking at the solution, you think that it's ordinary what? Water. It's because it's one phase. There's nothing, unless you test it. Looking at it, you won't even know. Am I communicating? But a heterogeneous mixture has more than one phase. Just get oil and mix liquid and liquid, oil and water. Mix them. They can't even mix. Three of us, they will separate. There will be oil layer and there will be what? Water layer. These two layers make up what? Two phases. Am I communicating? So that's what a heterogeneous mixture is. And because of the two phases, they are not what uniform. Am I communicating? Or get something like powder now. The powder you use for your face, put in water. The powder will not dissolve. True of us, it won't dissolve. And if you allow it for some time, the powder will do what? Will it settle? Huh? If you allow, have you tried before? Allow the mixture for some time. Will it separate? But this entire okay, good. It will float. Anyway, okay. It will not settle, but basically is that there will be what? Separation of powder and what? Water. It will not flow. It will not. The powder we use for a face, it's more like dust anyway. It will not do what? It's true. But there will be what? Separation of the layers. You see the powder layer and the what? Water layer. If you look through if the water if the whole mixture is in a tumbler, if glass tumbler, transparent, if you look through it, the water will just be free. Why the other one what? That what? Separation. Telling you that it's not what? Uniform. So that's an example of a what? Heterogeneous mixture. So the answer is correct. B is what? Whose composition is not what? Uniform. All right. Then number 2 says, which of the following changes is physical? Which of the following changes is physical? A. Adding of iron filings to aerated water. B. Adding sodium metal to water. C. Cooling of a solution of iron 2 sulfate to obtain dehydrated salt. D. Cooling of water to obtain ice. Cooling of water to obtain ice. What's the answer? D. Why did you use?
Because it's irreversible.
Is what? Irreversible. How?
As in, when water is ice,
Okay.
you can also freeze it.
Okay. Okay. Yes, you see, if physical change is what? Easily what? Reversible. And no new substance is what? Formed. But all the other ones, new substances are what? Formed. But the one of cooling water to form ice. You can get water at room temperature, the liquid one. Decrease the temperature by cooling it in the fridge. With time it will do what? Form what? Ice, right? Good. And if you melt it again, it will come back to the same what? Water. No new substance is what? Formed. So the answer is what? D. I agree with her. Cooling of water to obtain ice. The diagram let me sketch it. Number 3 says something like this. You have something like this. You have something like this. For those that we are not there when we gave the assignment, so but I believe others they have it in their notes. You have something like this. One is liquid 1. This is liquid 1, liquid what? 2 and liquid. Everything ended up in what? 100 at 100 vapor pressure, 100 atmosphere. I went together. Vapor pressure. Here is what? Temperature, right? And we have 20, 40. We have 20, 40, 60 what? 80 and what? 100, right? Here is what? The first point is here is what? 30, right? 30. This thing is vapor pressure, VP. Vapor pressure. Why here is what? Temperature. We have 30. We have what? 50. We have what again? Is it 100? 90 and what again? 100. Look at this diagram now. This is liquid 3. The question says, it can be deduced. Where? Okay, sorry, 60. Okay, thank you. 60. The question says, it can be deduced from the vapor pressure curves above that it can be deduced from the vapor pressure curve on the board as that A, liquid 1 has the highest boiling point. Liquid 2 has the highest boiling point, yes. Liquid 3 has the highest boiling point. Liquid 3 has the lowest boiling point? I need someone that can answer this question with logical, scientific, whatever adjective you want to use, explanation. Who can do that for us? Who? Try.
Liquid 3 has the highest boiling point.
Why?
Because 100 degrees centigrade is the highest boiling point of water.
Where? Here. They didn't tell us the liquid though. So don't say water. They didn't tell us the liquid. You know, this thing, there may be an error in the diagram. Hope you know. Just the scaling may not be correct. Hope you know. They didn't mention water here. So.
But I think that I understand any boiling point of a soil is 100 degrees centigrade.
That is water. What of other liquids? Who else? Who can answer this question? Chinawaya, answer this question fast. Those that were here when we treated this, I'm going to call you one after the other. You can't keep quiet here. I won't accept that. Aya.
You know that boiling point is when the water pressure is important, the water is very boiling.
I agree with you.
So, like, since boiling point normally occurs at 100 degrees Celsius, so the one that is likely that the boiling point will occur down 80 degrees is so it is.
Thank you. I have not got. Someone should give me a very good. Kadefa. Can see Chinwaya. Sim can see Chinwa. You had a shop here. Come see. Chinwaya. Let me start from Chin. See them here. Explain. We know you see. I need explanation. Remember I told you this is not that. It's not about answering the question. It's about knowing the reason for what. For your what? Answer. Explain, Oya. Can you hear her? Speak out.
Is 2 is at 4th, that is the highest boiling point. Then in liquid 3 is at 80. So that is the reason why it is the highest.
Can't say, let's say, you don't know, child. All right, please, let's not waste our time here. Now, is anybody here? You're not sure? Yeah.
Because the liquid with the higher pressure has the lower boiling point.
All right, thank you.
Boiling point unavoidably at the range. So
For an impure substance.
yes.
Michael, what's the answer? Sorry, Michael wasn't even there, sir, when we gave the assignments. But you should know it now. Look at it. You should know it now. Even though you were not there when you were there when we treated the boiling point. Boiling point. He was there. Okay, let's not waste our time now. We treated boiling and melting point before going to is your alpha. What's the answer? We all know the answer. We are just need the explanation. No idea. All right. Now, we define boiling point as the temperature at which the what? Vapor pressure is equal to the what? Atmospheric what? Pressure. So if you are heating a liquid, the molecules will be gaining kinetic energy, and the intermolecular bonds will be gradually becoming loosened, and with time it will get to a point vapor will be accumulating. Maybe if it is in a jar like this or a pot, this will be liquid, at this point, the pressure here, because the vapor they are getting energy, and as they gain the energy, there is this, about pressure law now. Pressure law, that as the temperature is directly proportional to what? Pressure. Have you heard about that? Pressure law. That temperature is directly proportional. So now, as they gain this kinetic energy, their temperature is increasing, and they gain this kinetic energy, the vapor will do what? Exert pressure. We call what? Vapor pressure. There's already a prevailing atmospheric pressure in that particular surrounding. Am I communicating? It will get to a point when the vapor pressure becomes equal to that of what? Atmospheric pressure. The liquid will start what? Boiling. Now look at this question. Look at this diagram. This on the x-axis, on the vertical axis, we have the what? This is what? Vapor pressure. Here, this is the what? Temperature. Now, watch. If you watch now, look at this one. Look at this. Look at this. At the temperature, this is not, the scaling is not correct, but it will give us an idea, okay? Let's trace from the what? Scaling, okay? Now, at what temperature? All of them ended up at this 100 watts vapor pressure. True or false? Now, let's trace if you know how to trace graphs, this is easy. Let's trace this. This is 100 atmosphere. At what temperature do we have this? 80. Am I communicating now? At 80, at temperature of 80, this one is at what? 100. Now, look at this one. That means at 80, this liquid one is what? Will start what? Boiling. Now let's look at liquid 2. Let's trace for liquid 2. At, even though this is not correct, but let's just trace it. At whether it is 120, but from the plot, everything ended up in 100, right? Yeah. So let's assume here at 90, here 7, here at 90, here at 95 or whatever. At 90 or 85 or 85, at a higher temperature than this one, right? The second liquid will start what? Boiling. But look at the third liquid at this 100. At a very high temperature. This one boiled at lower temperature, but at high temperature, this liquid 3 will what? Boil. So, which of them has the highest boiling point? Liquid what? 3. Am I communicating? Am I communicating? So that is the explanation for the number 3. Liquid 3 has the what? Highest what? Boiling point. Once you know the definition of boiling point, you are good to go. Just trace it. And now number 4 says the presence of an impurity. The presence of an impurity. Please, if you have any question, please don't keep quiet. Ask. Your silence means that you are what? Following. And keeping quiet, you're not helping yourself. Remember, you are paying for this. You are paying for this what? Service. So anything I say here you don't understand, please ask a question. The more you keep quiet, the more your money will go. True or false? True or false? If you keep quiet, your money will be going. True or false? So ask question. Don't keep quiet, please. Don't be ashamed. Don't say, they will say that I don't know. Let them say, but learn it. That's why you are here. Now, number 4 says, okay, the presence of an impurity in a substance will cause the melting point to A, increase, B, be stable, C, be 0, D, reduce. How? Explain.
Because the impurities reduce, because the impurities weakens the structure of the cell.
Now listen, she got it. Now listen. Basically, that's what is called test for purity. the best way to test for purity of substance, solid or liquid, once a solid has something else that is not that solid. You know, when you hear impure substance, what is it? What are impure? What do we mean by impure substance? Now, if something becomes an impurity, if it's not of your interest in a particular what mixture. If you have gari and sand mixed together, and what you want at that point in time is what? Gari. The sand becomes what? An impurity. Then if you have gari and sand mixed together, and your interest is what? The sand. The gari becomes what? An impurity. True of us? That's why it's a mixture. That's why we say that a mixture is impure. It's an impure substance. Because it has a lot of things mixed together, one or two or more. Now, two or more. Now, when a solid has an impurity, the melting point tends to do what? It will melt at a lower what? Temperature. And in fact, it's even a range. One, it will be less than the normal melting point if the solid is the only is pure. It will be less than, and not just that it will be less than, it will be a what? Range. It will start at a, because all the melting points of the constituents of that what? Mixture will be taken into what? Consideration. It will melt at a what? Range. But for boiling, for liquid, if there's an impurity, the boiling point will do what? Increase. That's why if your water may boil at 100 degrees Celsius, but your soup, because you have packed a lot of things, it may not boil at that same what? True of us, it may not boil. Now, that's why you can easily cook yam fast. Boom. Yeah, it only has what? Yam inside. True of us, but go and cook other thing. Go and cook rice, jollof rice, and other impurities, because water is what we have interest in. So at Stephen got it. And now let's continue. The answer is what? D. Number 5. Which of the following compounds and elements would sublime on exposure to the atmosphere? Which of the following? Okay. I thought you wanted to ask a question. Okay. Hello, are we together? Cynthia, what's going on? You've been quiet. Naman, did you do the assignment?
Yes.
Why is so quiet in this class? Even you, why are you quiet? Okay, I will start calling names now. Now, the question says, which of the following compounds and elements would sublime on exposure to the atmosphere? What's the answer? Iodine. Okay? You don't even need to heat it, right? Once you expose it on the atmosphere, it will do what? Gradually start going down and disappearing. True of us, we call it what? Sublimation. I agree with you. Number 6. Sodium chloride may be obtained from brine. Sodium chloride may be obtained. A question? I ask. You do what? You hit the iodine. No, it's not a must. Go and buy iodine. Even the normal iodine used to dress your wound. Buy it and open it. Okay. Go and buy it and keep. This one is not theory. This one has happened to me. I bought it. I didn't know that I didn't cover it well and left it. I want to be disappear. I didn't see it again in it. Who? You Kirafia. Chibuzo, you share an idea, right? About iodine, right? Have you ever experienced that? You should know.
Is room temperature and the atmosphere the same thing?
Atmosphere.
Yes, sir.
Atmosphere, room temperature is not the same thing, exactly the same thing. Okay? Depends on, if it's atmosphere, it may be in the room, it may be somewhere else. Am I communicating? But if you are specific room temperature, then you cannot talk about the atmosphere in that room. But atmosphere is a broad.
Because iodine can actually sublime at room temperature.
No, I'm saying now, he said that you must eat it, that he saw it in new school. Me personally, I have bought it. I have bought it personally and I didn't cover it well. After some days, I didn't see anything again.
Why is there confusion in some textbooks? Something like that. I know sulfur is like, but they will tell you that sulfur in textbook can actually sublime.
No, you need to. It's not. That one has for sulfur to sublime. There are different. It's not ordinary just heating. There are processes involved in that one. That one is a different thing. That's how you heat it. It will form something else. It will combine with oxygen and form something else. Yes. So you need to control a lot of things before sulfur can sublime. If you just, because they say that you heat it, you just heat it, sulfur will just combine with oxygen and start forming something else. It's no longer a physical what? Change. Am I communicating? But iodine, you must not heat it to do what? Sublime. I've seen that one. Now let's continue. Okay, it says that sodium chloride may be obtained from brine by A, titration, B, decantation, C, distillation, D, evaporation. What is brine? You cannot just say evaporation without knowing what a brine is. What is brine? I told you that if you are given any assignment, if you are given an assignment, gift, are you with us? Are you sure? You look as if you are lost. Don't worry. With time, with time, you become fully part of us. If you are given any assignment, try as much as possible. If you see any word you don't understand, look it up and learn it. What is brine? Tell us. No idea. So you just did assignment without even knowing what a brine is. I don't understand this.
It's one of the chemicals.
What is brine? What is brine? Kashi. Don't make sure Kashi me. What is brine? You don't know. Kashi, what is brine? What is brine? Brine is B-R-I-N-E. B-R. Brine. Salt water. And it's a solution of sodium chloride. Simple. You know about it ever since. Brine is sodium chloride solution. Brine is what? Sodium chloride solution. Brine is what? Sodium chloride what? Solution. Salt water. Sodium chloride in water. It will dissolve and form a what? Solution. What type of mixture is that?
Mixture is evaporation.
What type of mixture is that? Huh?
Okay, heterogeneous.
Homogeneous mixture. Now, so brine is sodium chloride what? Solution. Or salt water as you called it. So what it means is this: to recover sodium chloride from. They just put this brine to confuse you. They would have said sodium chloride solution. So you remain in that question and keep thinking of what is brine. But if you did electrolysis, you should know what is brine now. It's not true. So what's going on here now? You've forgotten all those things. Now, so it's by what? Evaporation. I think I've talked about this over and over. So I don't want us to waste time there. Number 7 says the movement of liquid molecules. The movement of liquid molecules from the surface of the liquid to the gaseous phase is known as the movement of liquid molecules from the surface of the liquid to the gaseous phase is known as A. Brownian motion, B. Condensation, C. Evaporation, D. Liquefaction. I heard liquefaction now. How can you liquefy something that is already liquid? It's called what? Evaporation. What is condensation? Adam. What is condensation? Gas to what? Liquid. Thank you. Gas to what? Liquid. Now let's continue. Number 8 says, when a solid substance disappears completely, when a solid substance disappears completely, what is it? Huh? When a solid substance disappears completely as a gas on heating, the substance is said to have undergone what? Sublimation, right? Good, I like that. Sublimation. Solid moving directly to what? Under normal circumstances, it should move to what? Liquid before going to what? Gas. But this one, it will move from liquid solid to what? Gas straight. Now, number 9 says, a mixture of petrol and water. A mixture of petrol and water can be separated through A. the use of filter paper, B. the use of a separating funnel, C. centrifugation, D. distillation. What's the answer? What's the answer? B is what? What's the answer? You don't know. What's the answer?
Use of separating from
What's the answer? Eh? Is it what? Try. What's the answer? B is what? What's the answer? C is what? Centrifugation. Okay. Chinwe, you don't know. You don't do the assignment. So I don't understand. Separating what? Funnel. Okay, so when you have immiscible liquids, right? Immiscible what? Liquid. Water and petrol, they are immiscible. In fact, on their own side, they will just separate. So you can easily do what? Use a separating funnel to do what? Separate. Simple. Centrifugation. That one you use sales of taste to. We still discuss it in our listing. We have not. We just started what? Separation techniques. We still discuss it. The idea of what I'm doing is to prepare your mind. Though I want to teach you how to study ahead. Simple. We'll still discuss it, okay? If I dwell on it, we'll not do what we have today. I just want to expose you to it so you prepare your mind. So that when we do it in this class, you understand it what? Perfect. And when you open your book to read, you understand. So please, if I give an assignment here, please try to do it. Don't just look for the answer. Try to understand the answer you are what? Ticking. It's very important you understand what you are ticking. So the answer is what? The use of what? Separating what? Funnel. Number 10 said, chromatography is used to separate components of mixtures, which differ in their rates of A. diffusion, B. migration, C. reaction, D. sedimentation. Migration. Explain what? Wait to see. Do you know I should not be explaining assignment I gave you to go and do? Does it make sense? Does it make sense? I gave you an assignment. It's a review. If listen carefully, hello, listen carefully. Let me, in case you don't know how to do this type of thing, this review, look at it. You are given question number 10. Chromatography is used to separate components of mixture. We define the array. The first thing you do is to either you browse or you open your textbook, just go through to what, just have an idea of what chromatography is all about. That's the first thing to do. Then look at this option. Pick these options one after the other. Diffusion. Just have an overview of what the diffusion is. Migration. Look at it. You now after that now the answer will just do what? Come out. So coming here now telling me to start explaining the assignment I gave you doesn't make sense. That means you know the assignment. Three of us. Because you have it's not a question I threw at you here. I gave it to you. You have the whole world in your palms by virtue of your phone. You have your textbook. You didn't go through it. You didn't do it. Then if you come here and be asking me a question again, that shows that you don't do my what? Assignment. And it's not a good thing. It's not what? A good thing. Okay? By review, I should sit down. Two of us. I should sit down. Then I'll hear what you did. You explain what you did. That's why it's an assignment. It's not a question I just put to you here now. No. I gave you the assignment. You go home, get your textbook, go through it yourself, find out these things. Prepare your mind towards that. But I don't know what is taking most of people's time. Okay, what is eating your time? That you can't do all these things. I'll be asking this question. What is consuming your time? What? You say what? What did you say? TikTok. Yes, I agree with you. I agree with you with my full chest. But jokes apart, seriously, if you are given an assignment, do it. It's not to look for the assignment, or it's not to look for the answer online. No, Obulia. These things, the answers are online. I don't need your answers. I need you to know why that is the answer. Fine, you can look for the answer, no problem. But try to find out why is it the answer, and why the other options are not the what answer. If you can do that, believe you me, by the time we are through with this topic, you become a professor of separation techniques. I'm telling you what will help you. It's not just about reading. If you take it seriously, any assignment I give, try to do it. Do it. That is a research. Look for explanations. Online, textbook, research, study. And if you see that if I'm here teaching itself, you have done something beyond what I'm going to teach itself. And it will enter well. But if you don't do it, you come here looking at you to know where to start from. So please take these things what? Seriously. So in our review, review is not for explanation. It's for me to hear what you are saying, what you have to say, what you did. I should even punish you for not doing the assignment I gave. Two of us. Yes. There should be what? Punish you for not doing the assignment I gave you. See, if you actually did this, if you are given an assignment and you actually did the assignment, the type of question you'll be asking, I will know that you did the what? The assignment. Because your question will now become maybe from what you have already established. You want to know more about that thing. I will know that yes, you actually did this what? Assignment. But there are two categories of people, that those that will just be there looking at you, they won't even know where to start from. They didn't do it, they didn't even open the book, they didn't even touch it. And it's not a good thing. So I don't want the type of response I received today, I don't want to receive it tomorrow. Now let's go over to what we have today, physics. Okay, sorry, I don't want to combine our physics. You know, we record our lectures. I don't want to combine our physics class with this review. All right, we'll stop here for today. See you next time. Bye-bye.